Okay, so this is lesson 6.2. Today what we're going to learn how to do is we're going to learn how to solve quadratic trig equations, okay? So yesterday we spent the whole period solving linear trig equations. So now we're going to take that one step further, and we're going to be doing some factoring, okay? Now, everybody here already knows how to factor. This isn't difficult. It's just going to take one extra step on top of what we've already done. You guys ready to go? Okay. All right, so quadratic trig equations are ones that involve products of trig functions. So breaking it up into those two factors like we looked at in problem 9 just before we did this. Okay? But before you do that, you have to know the notation for the squared. All right? Now, when we're dealing with x squared, we see it as x squared, and the squared is after the x. It's not the same when we're talking about trig functions. When we're squaring a trig function, you're going to see it in the middle, sine squared x. Okay? What you see here is the way that you put it into your calculator if you need to evaluate it at a value of x. Okay? So the first way is the way you write it. That's your notation. The second way is the way you enter it into your calculator if you're evaluating. You handle that? Okay. And of course, it's the same for sine, cosine, and tangent, that notation. Okay, so let's take a look at our first example. All right, so when you look at trig functions, it may help to first imagine sine and cosine is just a basic variable. We're very used to seeing quadratic functions. We're not used to seeing them in terms of sine and cosine. So if you need to, you can look at this in terms of a variable. What we can do is we can do a let statement. You guys know how to do let statements, right? You've done a million let statements. So what I can say is that's not an L, is it? No, not even a little. Okay, I can say let x, z, m, whatever. I don't really want to use x because I've got an x in there. I like A. A stands for Audrey. A. We're going to let A equal sine of x. Sine x, okay? And this is only if the trig functions being in there, you can't wrap your brain around it. So if you're really struggling because they're there and they're just too ugly to look at, you can do a let statement to make it a little bit easier for yourself to factor. Okay, but generally we want to keep them in there. So we're going to kind of get you used to seeing them. But if you need to do the let statement, do it. Okay, whatever way makes it easier for you to get through it. Okay, so I'm going to let sine x equal a. That means this is going to be a squared, right? Minus 4a minus 5 equals 0. Now, is that something you're used to seeing? Sure, and you know how to factor that, right? That's not bad. So that's all it is. It's just factoring, but instead of having the a, we have sine x. Same thing, okay? You ready to give it a shot? Okay. I'm going to go to the next page. We're on the interval from 0 to 360 degrees. Okay, so that's what we're solving on that interval, just so you know before I turn the page. All right, so here's my steps. Step 1. You're going to factor the left-hand side of the equation. Notice it says equation, not expression. Forgot the word for a second. Okay, it says equation, not expression. It says that because it's equals 0, right? Okay. Step 2 is to use that zero product law, so you take each factor and set it equal to 0. And then step 3 is to solve those linear trig equations, which we spent all day yesterday doing. Okay? All right, so let's try one. Here it is. Now, we just said if the sign is too ugly, if you can't factor it with the sign in there, you can do that let statement so that it's easier for you to see. Okay? A squared minus 4a minus 5 equals 0. So if you need to do that, you can. I'm going to do it in terms of sign because I need you to get used to seeing it like that, okay? So, how do they factor? Okay, a minus 5, a plus 1. Good. Now, great. If you need the a to help you out to factor it, awesome. Once you have it factored, you need to put the sign back in, okay? So, what's it going to be? Sine x minus 5, yeah. Good. And I need equals 0, because if I don't put the equals 0, what have I done? I've made it into an expression, and that's not solvable. Okay? Good. So is that bad? That's not bad, right? So again, if you need that a to help you factor, do it. But then make sure you pop back in that trig function. Okay? All right, so is it factored? Yes. What's my second step? Give me the name. That was my bad. Okay, that's going to be an odd sound on a video. It's just falling over for those of you at home. It's not doing whatever. Okay, what's my next step? My next step, zero product rule, right? So I have to take each factor, set it equal to 0. We have fun every day, don't we? Okay. Okay, there we go. You okay? Yeah, you look upset. All right, good. Not yet. Before we do the inverse, what do? Right, we got to isolate that. I really like that word. What word do I like? Isolate. I like it a lot. Okay, so we're going to add over that 5, and we're going to subtract over the 1. Something important. If you've already gotten a candy, don't say it. Something important about that first one. Why don't I need the inverse? It's bigger than 1? Yeah. So what does that tell me? There's no solution for that one. Awesome. If you already got one, you're not supposed to say it. Okay, so it's greater than 1. Watch it. It's greater than 1, so that part isn't going to have a solution, right? So we're going to reject that part. We don't have to solve it because we know that, what's the word? Sine and cosine do what in between two values? What's the word? Starts with an O. Oscillate. Okay. You got that? All right, I'll go. Okay, so it oscillates between what two values? -1 and 1. Nice job, Zach. And it oscillates between -1 and 1. Okay, it bounces between those two values. Sine and cosine do. All right? Okay. When is sine equal to a -1? 270. Awesome job. 270. Remember, going around that unit circle, right? Right here, -1. No, it's 3 pi over 2. Okay, good. So how many solutions do I have? Just one. 270 degrees. Oh, what do you think? It's not bad, right? Okay. We'll do lots more practice. We're going to spend all day on Monday practicing as well. Okay. The homework's going to be tough. We'll see how much of it you can get through. Yeah. All right, so basically what we're doing is we're solving two linear equations, right? So as long as you can get a factor, the rest is easy. Okay. Let's get a little bit harder. Remember, when we're factoring, let's start over. When we're factoring, it isn't always just two sets of parentheses. What does it multiply to be? What does it add to be, right? We also have to be concerned about GCF. We have to be concerned about difference of two perfect squares. So all of those things still come into play when we're factoring trig equations, okay? We can't pull out an x, and I'm glad you brought that up. You see these x's here? They are attached to the sine and the cosine. They are part of it. They cannot be separated. It is like peanut butter and jelly. Don't look at me like that. Not apples and oranges. Go ahead, get the phone. They're stuck together. Okay, yes, they're stuck together. It's like Mrs. Cucci in math. Stuck forever. Okay, so. Now you're leaving me? Where are you going? Okay, so how many variables would we have to do if we were doing let statements here? 2. Why 2? Hi, Brock. Nice job. Okay, so if you need to do let statements, let's use A and B. I'm going to let A be cosine, and I'm going to let B B sine. Okay, if you need to set it up this way, if you can't wrap your head around those trig functions, feel free to do it. Okay, so that's going to give me 2ab minus a equals 0. Awesome. Did you get one of these yet? You can have another one. Okay, you're going to pull out a GCF of a. Great. What's going to go in my parentheses? To be or not to be? That is the question. Is it 2b? I need more than just 2b. 2b minus 1. Don't forget that minus 1. He's like filled with Jolly Ranchers right now. Okay, 2b, be bossy. 2b minus 1. Okay, so that's with the variables, right? I want my trig functions. Thank you very much. That was beautiful. You can actually have another one for that. Okay. He's loaded up. All right. Okay, focus, guys. All right, so we're in factored form, right? What's my next step? Set them both equal to 0. Okay. All right, now, I'm not finishing this for you. I want you guys to go ahead and finish this one, and we'll go over it in a second. Okay, so when's cosine equal to 0, guys? 90 and? No? 270. 90 and 270. Good. Remember, you can also think about that cosine curve, right? When's it equal to 0? Here and here, 90 and 270. Okay? All right. Here you should have sine x equals 1/2, right? When's sine equal to 1/2? 30 degrees and? Remember, where is it positive? 150. Awesome. You have to go back and check your quadrants. How many of you forgot the 150? Yeah, you got to go back and make sure that you're hitting all of the quadrants in which sine is positive. Okay? Nothing. All right, how do I like my answers written? With braces, and what else? What kind of order? Ascending order. Okay? So 30, 90, 50, 270. I'll give that one to Emra. Boom shakalaka. Okay, how you doing? Holding together? Dakota, good? All right. Move to the next one. Okay, little bit harder now. Now, I want you to think about what I just got done telling you. You're going to have different types of factoring. You're going to have GCFs. You're going to have special rules. Special things happen with special type of factoring. You have 16 cosine squared theta minus 1 equals 0. What? Say it louder. Awesome. Difference of two perfect squares. 16 is a perfect square. Cosine squared theta is a perfect square. And 1's a perfect square, right? So we should know how to factor this. How's this factor? Plus 1 and? Good. Difference of two perfect squares, plus and minus, right? Awesome. All right. Now, notice it says round your answers to the nearest tenth. So does that mean it's going to be a pretty answer? No, not necessarily. They're not all going to be 30, 60, 90. Sometimes they're ugly, and that's okay, because real life is ugly. Okay, so you have to get used to that. So I want you to go ahead and find me my answers. Yeah. To find the angle, I take the inverse. But I always take the inverse of the positive. Okay, remember, the negative and the positive just tell you what quadrants your solutions are in. So that's a good question, guys. I have cosine set equal to a positive 1/4 and cosine set equal to a negative 1/4. How many solutions am I going to have? Where's cosine positive? You're right. Say it again. Yeah. Cosine's positive in the first and fourth. Where's cosine negative? Second and third. I'm going to have a solution in every single quadrant. Okay? What's my reference angle? 75.5, tenth of a degree. Read. Okay? 75.5 is my reference angle. It's also my angle in the first quadrant. Find me my rest of my solutions. Okay, what do we get, guys? 100, 154.5? Are you doing 180 minus 75.5? Thank you, 104.5. Okay. What did I write? 225? Sorry, that was my bad. Okay. So this one here was the reference angle. You don't do anything to this one. To get this one, we do 180 minus the reference angle. This is 180 plus the reference angle. And this is 360 minus the reference angle. Okay? Now, you have that yellow little Post-it note in front of you. Anything that you had trouble with today, I want you to jot it down, and I want it on that board or on that wall in the back before you leave my room. Your homework is pages 6 and 7. There's going to be some that you get stuck on and that you can't figure out. That's okay. Do what you can. We're going to spend all day Monday practicing quadratic trig equations. Okay? All right. Nice job today, guys.